Okay, so we're going to look at the angle between a line and a plane. And if we look at this diagram we've got going on here, we can see that we've got the line, and we're going to be interested in the direction vector of that line. And then with the plane, as we know, the only thing we can really consider is the direction of the normal. If we want to find the angle, it's the one indicated there with the red arrow, phi, but it's pretty easy to find the angle theta, using our trusty formula from before, that cos theta is equal to the dot product of the two vectors, so in this case n and d, divided by the magnitudes of them too. So we can find theta, and then to work out what phi is, because that pink creates a right angle triangle, we would do 90 degrees subtract theta, or we could know that the relationship between cos of an angle and sine of its complement, i.e. 90 minus it, would be equal to each other. So instead of cos theta, we can go straight into sine of phi. So the inverse sine of that same formula is going to get us directly to the angle between a line and a plane. If you want to use the old formula in yellow and do cos theta and subtract it by 90, obviously that's fine, but if you understand the connection, then you can go straight in with the arc sine of n dot d over mag n mag d. So in example 52, we're going to find the angle between the plane and the line, which is given parametrically. So in purple, I've already written the equation of the plane and pulled out the normal, so r dot n equals 8. So the normal there is 1, 2, negative 1. And I've written the parametric equation, the x component being 0 plus 1t, the y component being 1 minus t, and z 3 plus 2t. So then I've pulled out the direction of the line to be 1, negative 1, 2. So in order to find the angle that I'm interested in, I'm going to use the inverse sine of the dot product, which is d dotted with the normal. Because we're interested in the acute angle only, we're going to take the absolute value of that if it turns out to be negative, and divide it by the magnitude of d and the magnitude of n. Okay, so that's sine phi equals the dot product divided by the two magnitudes, and then we do the inverse sine of it. So that ends up being, when we do the dot product of our two vectors there in light blue, we get 1, negative 2, negative 2. And we would take the absolute value of that. And then we've got root 6 for one magnitude, and the other one is also root 6. Okay, so what that ends up being, if we simplify this down, we end up with the inverse sine of 3 on 6, or of a half, and we know what that is 30 degrees. The angle between them would be 30 degrees. Okay, and that's how we find the angle between a line and a plane.